Now in this one we want to look at the square root function. That means f of x is equal to what?
Square root of x.
It's the square root of x. So let's think about what the t-table of values will look like for this guy. Now, before I get to this, though, is everybody okay? For my cubing function, what was the domain and range for this guy? What was his domain?
Negative infinity to infinity.
It was all real numbers. What was the range? It was the same. Remember what we said for these guys? But for the most part, their domain should be all real numbers unless we have what to worry about? It's okay if you don't remember. That's what I'm here for. Your parabola, what's his domain? Does he have any restrictions on his domain? 0 is not a restriction. Here's 0 right here. It gives you 0.
The domain doesn't, but the range does.
Well, the domain is all real numbers, right? There's no restriction on what you can plug into this expression, right? There's no expression, there's no limitation as to what you can plug into x to the third. What's your range here for this?
0 to infinity.
0 to infinity. So a cubing function has no restrictions on the domain. You can plug anything you want to into the x cubed. What about the square root function? Does he have any restrictions on the domain? He doesn't? Look back at what we said in the notes about restrictions on your domain. There's two main things that we're experiencing right now that will limit our domain, that limits what we could plug into an expression. One of those would be any number that makes the denominator equal to 0, or anything that would give you a negative radicand for a square root. So the values that I plug into this square root guy must be what?
Positive.
They're going to be, well, non-negative, because 0 is neither negative nor positive, but I can plug that in. The square root of 0 is 0. What's the square root of 1? Am I going to plug in the square root of negative 1? I plug in the square root, but if I plug in negative 1, I get something that is what? Complex. I don't want that. What's the square root of 2? Something.
Square root of 2.
It's approximately 1.414. Do you want to plot that guy?
No.
Not really. You want to plug in numbers that will give you nice numbers on the outside. So what would you really like to plug in?
4, 9, 16,
4 gives you 2. 9 gives you a 3. Square root of 9 is 3. Do you all agree?
Yep.
Yeah, square root of 9 is 3, not 9. So here's 0, 0, 1, 1, 4, 2, and 9, 3. What kind of shape do you see this guy taking? It's like a sideways parabola, right? Kind of looks like a ray, but rays are just like lines and line segments. They're straight, and this guy's not straight. But notice your key point. You start here at the origin at 0, 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. You plug in the nice values here. Does this guy have any symmetry? We've talked about things having symmetry about the y-axis or the origin.
No.
Kimberly, you're shaking your head no? If I were to turn this guy 180 degrees, it doesn't look right? So here's here's square root of x. If I flip this 180 degrees, is that not the exact same thing?
In a manner.
Does that look like the exact same thing? This guy's going over here, this guy's going backwards to the left, is that right? So does he have origin symmetry? No, this guy doesn't have any symmetry. What a loser, right? Yeah, let's make fun of him and call him names. What, he's a loser, baby, so why don't you kill him?
Yes.
Double barrel buckshot.